Assalamualaikum. My name is Amir Irfan bin Ramzan Asri. So today I will explain to all of you about arithmetic progression and geometric progression. So basically, a sequence in mathematics is a list of items arranged in a consecutive fashion, with one item appearing either before or after the other. The total of a term sequence is called a series. In other words, a series is a sequence of number that have been added to one another. So in this topic, we will learn more in arithmetic progression and geometric progression. So what is an arithmetic progression? A sequence is called an arithmetic progression if the difference between a term and the previous term is always the same. The formula is an plus 1 minus an equal to constant, which is we call it d. So an plus 1 is a term after an. So an plus 1 is the second term in the sequence, and an is a first term in the sequence. For example, we have one sequence which is 1, 5, 9 and 13. So what is the common difference in this sequence? So by using the formula, an plus 1 is 5 and an is 1. So 5 minus 1 equal to 4. So common difference in this sequence is 4. So next is general term of an arithmetic progression. So we need to find a value of an. So the formula is an equal to a plus n minus 1 bracket multiply to d, and then sum of n terms of an arithmetic progression. We need to find the sum which is Sn. So the formula is Sn equal to n over 2 bracket 2a plus bracket n minus 1 multiply to d. So next is geometric progression. So what is geometric progression? A sequence of non-zero numbers is called a geometric progression, which is GP, if the ratio of a term and the term preceding it is always a constant quantity. The constant ratio is called the common ratio of the GP. So the formula is an equal to a r the power of n minus 1. So r is a common ratio.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharul Razif, and I'm about to discuss about our filler table in question 1 and question 2. For our question 1, which is a guy bought a second-hand vehicle that cost 21,600 ringgit. He took a loan to help him pay for that vehicle. In the first month, he paid 300 ringgit to settle his debt with the bank. Every new month, he will add 50 ringgit to speed up his loan payment with the bank. How many years that it takes for him to settle the loan? The fact that we can extract into our filler table is, first, a guy bought a second-hand vehicle that cost him 21,600 ringgit. He took a loan to help him pay for that vehicle. Second, he paid 300 ringgit in the first month. Third, he add 50 ringgit every month to his payment to settle his debt quickly. For the ideas, first, he buy a second-hand vehicle because it's cheaper than a new one. Second, he took a loan because he cannot afford to pay it by cash. Third, he paid 300 ringgit in the first month because his monthly salary can only afford the amount. Fourth, he can add 50 ringgit every month because he do another part-time job. For the learning issues, first, by using arithmetic progression formula, which is Tn equal A plus in bracket n minus 1 close bracket D, can we find the total of month needed for him to pay the loan? Second, by divide the amount of Tn by 12, can we find the total of year that he need to fully pay his loan? The action plan that we take is, first, find the solution of the problem, and second, refer to reference source such as from internet, reference book and YouTube. For our second question, which is a factory can produce about 500 pieces of pencil in 1 hour. Every hour, the production of the pencil increases by 1.5 times. A pack of pencil contains 30 pieces of pencil. How many pack of pencil can the factory produce in the next 10 hours? The fact from our filler table is, a factory can produce about 500 pieces of pencil in 1 hour. Second, the production of the pencil increases by 1.5 times every hour. Third, a pack of pencil can fit 30 pieces of pencil at one time. The ideas for our filler table is, first, the factory produce so much pencil to supply it to the bookstore. Second, the factory increases the production of the pencil by 1.5 times every hour because the demand from the bookstore is high. Third, a pack of pencil can fit 30 pieces of pencil because their target buyer are from students and teachers. The learning issue in our filler table is, by using geometric progression formula, which is Tn equals to AR with the power of n minus 1, can we find the amount of pencil that can be produced in 10 hours? Second, by dividing the amount of Tn by 30, can we find the amount of pack that can be produced by the factory? The action plan in our filler table is, first, find the solution of the problem. Second, refer to reference source such as the internet, YouTube and the reference book.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin from Muhammad Zamri. So today I'm gonna explain to you all about the problem background. Based on the question 1, a man want to buy a vehicle worth Rm 21,600. In the first month he pay Rm 300, and every month he will add Rm 50. To solve the problem, we can use the arithmetic progression. The formula for arithmetic progression is Tn equal to A plus D in the bracket n minus 1. So before we solve the problem, we need to determine what is the value for Tn, A, D and n. The question asks us for find the how many years. So how many years equals to n? So in the equation we need to find n. 21,600 is Tn because Tn is the final value. 300 ringgit equals to A because 300 ringgit is a constant value, and D equals to 50 because D the value that we add on the constants. So now we go to the second question. Based on the second question, a factory produces 500 pencil sticks within 1 hour. The production of the pencil is 1.5 times every hour. A pack of pencil contains 330 pencil rods. How many pencil produced in 10 hours? To solve the problem, we can use the geometry progression. So the formula for geometry progression is Tn equals to AR, the power of n minus 1. So for first of all, we need to determine the value of Tn, A, R, and N. So how can we determine them? So the 500 pencil is a constant value, so it will goes to A, the value of A. So A equals to 500. The production of pencil is 1.5 times. So R is ratio. The ratio is 1.5. And how many pencil produced in 10 hours? So the time is N. So in this question, they ask us to find the value of Tn, and that's all.
Hello, my name is Alif Hakimi and I'm gonna present the solution of the case study. Question 1. A guy bought a second-hand vehicle that cost 21,060 ringgit. He took a loan to help him pay for that vehicle. In the first month, he paid 300 ringgit to settle his debt with the bank. Every new month, he will add 50 ringgit to speed up his loan payment with the bank. How many years that it take for him to settle the loan? From this question, we know that we can use the arithmetic progression formula. So we can use formula Tn equals to A plus D in the bracket n minus 1 bracket, where A is the first term, D is the common difference, and N is the total month that he need to pay. So we use that information into the formula, so we can get 21,600 ringgit equals to 300 ringgit plus 15 in the bracket n minus 1. So we must search the total of month for him. So 21,600 ringgit equals to 300 ringgit plus 15 in the bracket n minus 1. So we bring the 300 ringgit to the left. So it will be 21,600 minus 13 equals to n minus 1 in the bracket 15. So it will get 21,300 equals to n minus 1 in the bracket 15. So we bring the 15 to the left. So it will be divide. So it will be 21,300 divided by 15 equals to n minus 1. 21,300 equal divide by 15, it will get 426. So the formula we will get 426 equals to n minus 1. We want to search the n, so bring the 1 to the right, to the left. So n equals to 426 plus 1. So n we will get 427 months. So the question want the answer in the years. So the n divide by 12 because in 1 year we have 12 months. So 427 divided by 12, we will get 35.6 years. So he needs 36 years to fully pay his loan with the bank. For the question 2, it states that a factory can produce about 500 pieces of pencil in 1 hour. Every hour, the production of the pencil increases by 1.5 times. A pack of pencil contains 13 pieces of pencil. How many packs of pencil can the factory produce in the next 10 hours? From this question, we can know that we can use the geometric progression formula, which is Tn equals to AR to the power of n minus 1, which is R is the common ratio. So we know that Tn is the amount that we don't know, A is the 500 pieces of pencil, R is the 1.5, and N is the 10 hour. So we use that information and insert it in the formula. So we will get Tn equals to 500 multiplied with 1.5 and to the power of 10 minus 1. So we will get Tn equals to 715 to the power of 9. So total pieces of pencil can be produced is 91,221. So the total of pencil that can be produced we already know. So the question wants us to search the total box that can be produced. So we will divide by 13 because one box of pencil is equals to 13 pieces of pencil. So 91,221 divided by 13, we will get 614. So the factory can produce 640 boxes of pencil in 1 hour.
Hi, my name is Sufi and I'm going to tell you about the discussion. So, the analysis of both scenarios, one involving a loan repayment strategy and the other one is examining the production output of a pencil factory. It provides valuable insight into mathematical application in real-life situations. To enhance the clarity and comprehensibility of such reports, incorporating visual elements like charts or graphs could significantly improve the reader's understanding. Visual aids, especially in the loan repayment scenario, could help illustrate the impact of incremental increases on the repayment period. Additionally, including comparative analysis or sensitive assessment would add depth to both reports, it offering a more robust evaluation of various factors affecting outcomes. For the pencil factory analysis, visual representations of the product's growth could facilitate a better understanding of the exponential increase. Furthermore, both reports could benefit from a discussion on potential challenges or risks associated with the respective strategies or scenarios. This would provide a more comprehensive view for readers and allow for a more balanced interpretation of the findings. In conclusion, supplementing mathematical analysis with visual aids, comparative assessment, and a discussion of potential challenges will contribute to more comprehensive and reader-friendly reports in both scenarios. And I'm going to tell you about the conclusion. So, in conclusion, the exploration of mathematical applications in real-world scenarios involving both loan repayment strategies and production dynamics in a factory has underscored the versatility and practical significance of mathematical modeling. The analysis of loan repayment highlighted the impact of incremental increases on expediting debt settlement, showcasing the potential benefits of strategic financial planning. Simultaneously, the investigation into the exponential growth of pencil production emphasized the compounding effect of consistent incremental increases over time. Both scenarios underscore the importance of considering mathematical tools as invaluable aids in decision-making processes, whether in personal finance or industrial management. This exercise has deepened my appreciation for the role of mathematics in providing insight, optimizing strategies, and addressing challenges across diverse contexts.